So I'd like to thank you for making this your first breakout session of VMworld, and hopefully it's going to be a great VMworld. So my name is Graeme Gordon. I'm a senior staff architect in the EC business unit. My role is to head up reference architecture. I kind of don't do this alone. This is a big team effort within the business unit. And what we're trying to do with these reference architectures is provide guidance in terms of how you bring all the products together, how you create solutions based on our products. And one of the things we like to look at is teaching you how to architect. It may not show you exactly what you want to architect, but it should hopefully teach you the principles. So what we're going to do today is talk about Horizon reference architecture, how you architect all the different components in that, and how you approach it. The standard disclaimer, you're going to see lots and lots this week. Everything we're going to talk about here is current. We only build reference architectures on release product. Right? There's no point talking about futures and maybes and what haves. We build this on what we release, and then we also take all those products and we build an environment and make sure everything we then write in the documents is actually realistic. You're going to be able to do that. And if there's any issues, we try and work with the product teams to overcome them, or we put information into the documents to help you overcome it as well. If we hit the issue, let's explain it and make it easy for you. So these are realistic, but nothing futures. So what we're going to talk about today, we're going to look a little bit very quickly at what a reference architecture is, how we approach a project, some of the methodology. Bulk of today will be into designing the components or the products. So Horizon, Identity Manager, App Volumes, UEM, small UEM, and Unified Access Gateway. We'll look at the principles of architecting those. Now, that's a lot to cover, so I am not going to go into the nth degree of detail of each of those. The document does. So I recommend, and I'll give you a link to the document, go and read all that. So I won't go into deep technical detail on that. What I will do is give you the guiding design principles of each of those. And I'll give you the understanding, hopefully, of how I approach architecting Horizon. How do I architect app volumes? What if I want to do disaster recovery? What's my principles there that I need to follow? So that's my objective today. Now, we have to put in a slide positioning this, Horizon is part of Workspace ONE. My segue here is, when you're architecting, you need to remember two things. You need to understand what the enterprise wants you to do. And a lot of the enterprise will be, we need this secure, we need this redundant, we need this available. Users don't really care about a lot of that. So we need to balance this. What do the users expect? Are we delivering what they need? Are we delivering a great experience? Because if we don't balance those, the business won't like it, the users won't like it, it won't be a success. So just remember that when you're designing. So what's in a reference architecture? What we took, the approach was, we tried to make this modular. We tried to make this a way that you could adapt this to whatever you're trying to do. And the way we did this, we base it around about use cases. And we come up with a series of use cases that are hopefully generic enough, hopefully modular enough, that you can say, I don't like that component, or I need an extra component in there. I'll change what's in that use case, and it'll fit what I need. Right? And out of those use cases, we drive out needs, requirements. And then in the document, we're going to into a lot of the design and architecting of the products. So when I'm designing stuff like app volumes, how do I scale it? Right? How do I make it highly available? How do I make it redundant? And how do I kind of overcome some of the challenges like external components like databases? What are the considerations? So we talk through each of those, and we also then give you decision points in the document. So there's some choices. Here's the choice we chose when we went and built and validated the environment. Right? You can choose the same one if the reasoning is the same, but hopefully we're giving you the logic there you can make a deciding factor. The other thing we put in here is lots of tips and tricks. So if you need to build stretched SQL clusters to provide some of this with SQL always on, how do I do that to provide the Identity Manager? So we've given you a complete guidance there and how you stand that up. Right? Lots and lots of tips and tricks there. So about 350 pages long, so lots of content, and obviously I'm not going to cover it all today. So recommend you go and dive into it. And lots of people will dip in and out of it as well. We actually structured the document around about a methodology, and this is what we preach to kind of our PSO and other consultancies. Form a kind of methodology you're going to go through in a project. Don't just rush in and say, we need desktops, we need Horizon. Let's kind of work out, how many connection servers I need and stuff like that. What we say is, let's start by understanding what your business is trying to achieve. And if you don't understand what your business is trying to achieve, how do you ever measure if you're successful? So go back and ask the questions, understand what they're trying to achieve, and then you're going to match those against use cases, match those against requirements, and then out of that will fall a bunch of technology requirements. Yes, you need Horizon, maybe you need Identity Manager, possibly app volumes and stuff like that. That'll get driven out of those requirements. And ultimately, you'll build an infrastructure, you'll design infrastructure to support that, and at the tail end, you'll start building what we call services, right? What are you going to hand over to your end users for them to consume, right? That's just not going to be a desktop. It's going to be other things as well. You could need applications in there, might deliver through app volumes, you might bring SaaS applications in there, you might do other stuff. So you need to kind of craft that whole service and hand it and deliver over. And then importantly, measure it. What is the user experience like? Did you meet the requirements? Is it successful? And if not, go back around the circle and iterate. So that's the methodology we preach. This is not going to work. So when we talk about business drivers, these are samples we put into the paper. Yours may be similar, yours may be different. The idea here is go back and interview your business owners. What's important? What are you trying to achieve? Is it a faster application delivery? Are you trying to reduce the complexity of operations? Are you trying to give users mobility or bring BYD in? Are you trying to kind of reduce help desk calls? Understand what the drivers are and understand then how you can mold in the technology to fit those problems. Next thing you're going to do is identify some use cases. And I'm not saying put all your users into buckets, but kind of look and see whether there's similar patterns, right? We can kind of categorize working patterns of different users together and loosely group them together into what we call use groups. And then go interview those users. And out of those users, you're going to drive in a bunch of requirements and understand what the end users think they need. Right? So you've now got what the business needs, you've now got what the users think they need. You're closer to understanding the problem. Right? Some of the requirements, are going to be, well, I need to be able to work from anywhere. Right? I need to be able to install applications. Right? Understand the challenges and what you're going to need to deliver. Now, don't take that as a full set of requirements. You need to think past that. And you also need to think whether some of the requirements are nice to have or whether they're essential as well. Right? These are samples. So next thing you want to do is, right, about to go and build all this infrastructure. What infrastructure do I need? So this is a key point. I understand the requirements, I understand my use cases. So for each use case, I should start to be able to draw a picture, what we call a blueprint, that describes what my end solution is going to be. So the example I've given here is a burger and fries. Right? My use case is I have a hungry user, and he said he wants something he can pick up with his finger and eat with his mouth. At this point, I know a burger and fries is going to satisfy all the requirements I've gathered from the user. I don't know how I'm going to create it. Right? I don't know how to create chips. I don't know how to scale creating chips to make it redundant. I don't know how to create the kitchen that I need to create the chips. That's going to come. All we're doing at this point is describing what the end solution is and what the components of that end solution are made up of. Then we're going to work out how to go and build it. How to build the kitchen, how to make the burger, how to make the chips. What you'll end up with is a series of pictures. We kind of tried to make them modular, you can adapt them and stuff like that. This one's, for a desktop delivery. From the left, you've got a user consuming a service. The service is made up of an instant clone with a bunch of applications delivered. And we're going to deliver it through something called a master VM. Right? We're going to create a pool of desktops. No idea how we're going to do that or what we need to do that. We're going to deliver some applications. We're going to deliver some profile information with User Environment Manager. Right? We don't know how to create those. We don't know how to scale them. But we at least know now that we need them to satisfy this use case. Right? What the business is asking, what the users are asking, what the requirements are, this is what we need to answer it. We can validate this with the user. If I delivered this service to you and describe the service, does that meet your needs? You'll also be able to drive up disaster recovery or high availability use cases. And we'll talk about this from the user's perspective. So when we talk about active-active or active-passive, we don't talk about data centers really. What we talk about is that service we're delivering to the user, what do we want to do? Do we want it delivered out of a single data center, or do we want it to be able to consume from multiple data centers? Typically, what you're going to do is an active-passive. This is the example I've given here. The user is consuming out of site 1 actively. Certain components we can reproduce. So if they're consuming a virtual desktop, let's give them an equivalent desktop in site 2. Let's reproduce their profile data. Let's take all the applications and make sure they're also available in site 2. And then we can make a failover decision. We can build that in, right, if disaster recovery is required. So let's go into some of the principles. Before we get into the products, let's just make sure we understand some of the principles we need to follow. This clicker is going to drive me mad today. So, 4 things we want to bear in mind when we're looking at architecting a solution. Right? We want to make sure it's scalable. Right? What are the rules? Right? How do we add in availability? Right? How do we make it redundant? Right? Is redundancy within a data center important? Is redundancy across data centers important? And also understanding then the cost implication there. The other thing we need to think of when you get into redundancy and that site redundancy issue is data replication. Right? It's often great to say, yes, I want full data center redundancy and I want users to be able to go to site 1 and also to site 2. But what's the cost of replicating all their data? Right? Do I want to replicate their wallpaper? Do I want to replicate their OST files? Or do I not really care about that in a disaster? So you can make calls in terms of what you replicate over to the second site. But a lot of multi-site design comes down to that cost of data replication, how fast you can do it, how much you're willing to do, and then that recovery point objective. So a couple of designs we go with Horizon. When we look at 2 sites, as I mentioned, look at it from the user's perspective. Is that user going to have an active service out of site 1 and passively served out of site 2 for disasters? And that's more typical. And that's down to that data replication challenge. Now, the important thing here is when we're dealing with Horizon, we want to keep all the connection servers in a site. So what we do is we build up a view pod of connection servers in site 1. We build up a completely separate view pod in site 2, and we join them together with cloud pod architecture. And then we use what we call global entitlements to stitch the 2 together. Now the important thing here then is for the user, their service is out of site 1, and it has to be a conscious decision for us to switch their service over to site 2. It's passive until we say, no, something's wrong with site 1, we're going to fail you over and recover you into site 2. And now your service is getting delivered out of site 2. So the comparison is an active service. And you may go, this is what I want. This is what all my users want. Well, your users don't really care. The users always want to be able to access their information. The challenge with an active service where you're saying, Graeme could be going to site 1, and he could be changing information, and he logs off, and he goes to reconnect to the service I'm giving him, and he's now going to site 2, because he can go to either site. I don't really care. That's great. We can create a pool of desktops in both. We can do a global entitlement. That's easy. We can copy the user environment manager data to both sites. That's relatively easy. The challenge comes with your file data. Right? So if I logged on to site 1 and I changed an Excel document, and I save it into site 1, and then I log off and I go, oh, I forgot to change something, and I log back on and I'm in site 2 now. Has that document replicated over? Right? That's the challenge, that data replication. The infrastructure, the service is probably the easy bit. So just think when you're talking about active, passive, what is the user experiencing? We don't really care about the data center usage. Right? Now if you say, well, I want to use both my data centers, that's fine. Split half your users active into site 1, half of them into site 2. You're going to achieve kind of usability in both data centers. Other thing we come across is, well, you talked about all my connection servers in site 1 and then a separate pod in site 2. We keep on coming across people going, no, I'm stretching my pod. I've got connection servers in site 1, and I've got connection servers in site 2. They're all part of the one pod. I just want to be ultra clear. This is not supported. It may work for you, and then you'll start experiencing funny stuff. Right? There's reasons it's not supported, and it's down to how connection servers communicate with each other. There's a Java bus message that communicates the state of desktops. So if connection server 1 gets the desktop and gives it out, it needs to communicate to all the other connection servers. So upshot is, don't stretch your connection servers over 2 sites. Now what is supported is this model. So we can use a stretched vSphere cluster with stretched vSAN underneath. And with that, we're going to replicate with the stretched vSAN all the data, all the disks from one site to another, because that's the storage level presenting it. The important bit here we're going to do is all the connection servers are going to get pinned into one site, into site 1. And if site 1 fails, then vSphere HA is going to fail them over and recover them into site 2. So they all stay together. So we don't kind of split the connection servers as we did in the unsupported model. Right? So this kind of gets around it. I can have a pod that will exist over both my locations, but I'm kind of keeping it actively in one site at one time. So typically what we see is the separate pods for most use cases. This is more applicable to places where people are using full clones, right? Where I've got kind of full VMs and I need to replicate what's inside them. This kind of addresses that use case quite nicely. Now, other key considerations when we get into multi-site design or disaster recovery, or even a service, is when you're delivering that service, what are you going to deliver? And it's important not just to think about the desktop of the application, because users expect more than that. They want their personalization there, they want their applications there, they want their data there. So don't, expect to deliver this an empty desktop. It'd be similar, if a user came to you and said, my laptop died. Give me a replacement. You wouldn't just pull a brand new laptop out of a box and give it to them. There's customization that needs to happen. There's personalization. How do they get to their files? How do they get their application? Some of it we may care about, some of it we don't care about. And you can make that call when you do disaster recovery as well. I don't need to recover your wallpaper. That's not essential for the business. But I do need to recover your applications and your data. Right? So think about what you're going to recover, how you're going to replicate that, and what that means for cost. There is going to be stuff that's non-multi-master. So VMware software and non-VMware software. So I'll go into the architecture of Identity Manager, but essentially it has a master site. One of my sites has to actively run my Identity Manager instance. So which one is it going to be? So pick a role for that. And then understand how I recover it. There's going to be non-VMware software as well that's non-multi-master. So even stuff like Active Directory roles. So where are they? And then what relies on them? How do I recover them? In what order do I need to recover them? When you're placing those users, and especially if you've gone for those active-passive services, how am I going to align my users? Which is our active site for groups of users or use cases? Right? Where are they going to get placed? Where am I going to recover them? Right? And then how much capacity does that mean I need? Right? If I'm going to do disaster recovery to a particular site, have I got capacity to cope with that if I have outages in all the places I care about? This one's a big one. Back to this data replication issue. Right? Understand what the business is asking from a recovery point objective and a recovery time objective. Right? If your business says, we want 1 minute failover to our disaster recovery, okay, so you've got a user in site 1, we've had 1 minute, I see some laughs. We've had people say, I want 0 minute, and I went, how does that work? So 1 minute from site 1, well, we're going to press the button, we're going to start the service in site 2. There's all my files replicated. That Excel sheet I was replicating earlier, can I replicate that? Can I replicate everyone's files within that time period? Right? If I'm using stuff like @volumes, writable volumes, They're big. Can I replicate those? Can I make sure they're consistent? Are they in site too? So understand what's achievable within what you're being asked, and then you're going to have a discussion. Well, I can recover 80% of the service within that time period. Is that good enough to get the business running? Or do we need to extend out the recovery point objective? And it's not 1 minute, it's 5 minutes now. So you've got to have that discussion, understand what you've been asked to do, whether it's achievable, or whether your replication technology needs an increase. Maybe we need more bandwidth between our two data centers. Right? So don't just look at your RTO, RPO as being solid figures. This is what we need to meet. Everything needs to happen within it, because there's a level of physics, stuff is not going to actually be achievable. The last one is non-VMware software. So stuff like SQL especially, we rely on SQL for stuff like Identity Manager and the AirWatch services that I won't be talking about today, but they rely heavily on SQL servers. So when we do Insight, we usually use stuff like Windows clustering. And when we do across sites, we use SQL Always On. And SQL Always On is non-multi-master. There is one node in there, it's my write node. So where is that and how do I recover it? And again, understand how you architect these non-VMware components and then how you recover them if you've got an outage. Okay, let's move on. Let's actually talk about products. Before we talk about products, this is what you're going to aim for. Nice and simple, isn't it? This is actually the simplified version. I took all the AirWatch components out there last night. And the thing I put it in here is, this is what you're going to try and architect now. So the question then is, you try and look at it all in the one picture. It's a bit daunting. Right? Where do I start? There's lots of moving parts. So the way we look at it is let's take each product individually, let's architect them, scale them, and then at the end we'll integrate them back together. Right? And we'll create a working solution built out of all these moving parts. Right? So we look at Horizon, how many connection servers I need, do I need unified access gateway, how do I scale and design that? And we look through each of the products, and we try and hit a bunch of questions. What version am I going to use? Right? Why am I going to use it? Have I got compatibility issues with third-party software? Maybe I'm doing single sign-on with Imprivata, so what version works there? Am I going to use a SaaS version of the product? Am I going to use on-premises? Right? Again, both may address your needs, but it may be a business decision rather than a technical decision. How do I scale it? How do I make it available? How do I do multi-site? Any third-party dependencies? If we're doing virtual desktops, what about networking, authentication, etc.? We need to think of all these, the impact on the infrastructure, and then come up with a decision on each of them. So with Horizon, one of the guiding principles we have is the block and pod. And what we've done with the block and pod architecture for Horizon is try to come up with a way of giving you a repeatable block size approach to designing. You get that block right, you just repeat, repeat, repeat. You can scale up as far as you want, essentially. Right. Inside each block, we're going to have a virtual center, and that's kind of the boundary of the block. And then we're going to have one or more vSphere clusters. That's my block is where I run my resources, my desktops or my RDS8 servers delivering my published apps. And then we, as I said, we scale out by adding more. And we say roughly a block can be 2,000, 4,000, 5,000. I'll show a slide with the numbers. And then we create a pod round about it. And a pod is constrained by the number of connection servers. The connection servers all come into Replica, and they're going to do that communication between them. So it doesn't matter which connection server I get to or which desktop I'm trying to get to in whichever block. I can hit any connection server and get directed to block 1, 2, or 3 or a desktop in them. Right? So how big a block can I go? There's actually 3 numbers right now. We're trying to rationalize this down. If my block is only running instant clones without app volumes, that virtual center will handle about 5,000 virtual machines. If it's linked clones without app volumes, it's 4,000. These are, again, numbers we tested and recommended against. The minute, unfortunately, we introduce app volumes, right now the recommendation is 2,000. We are doing active testing to try and bring that number up. And you'll probably see customers who are running higher numbers than that. We're trying to give you the guidance here that we know will work in your environment in any circumstance. The other part then is how big is my pod? So my pod can have up to 7 connection servers. Now each connection server can actually handle 4,000 connections, but as a best practice we actually say keep it to 2,000. Right? You may go, well, I'm reading on the screen at the bottom, you're saying keep the pod to 10,000, Graeme. Well, 7 times 2 is 14,000. Even with redundancy, that's 12,000. So what gives? So we bring it down by another 2,000 because when we bring a pod into a cloud pod architecture, 10,000 is a very safe number. If we build each pod to 10,000, they're all communicating to each other. We know stuff will work. So keep your blocks within the 5,000, 4,000, 2,000, depending on what you're running. Keep your pods to 10,000, and you will have no real issues. Now, there's always nuances within environments, but this is what we see as the best practice and what works within every environment we talk to. So just because I can do 5,000 instant clones, doesn't mean that's what I should do. Right? So if your environment only has 5,000 users, are you going to build a single virtual center? Right? Put all the 5,000 desktops against that single virtual center. That may be the right thing to do. It probably isn't. Right? Are you going to put all your users in one failure domain? If something happens to that virtual center, what's my impact? And there's 2 things you need to think of here. Right? If I lose my virtual center, what happens? Well, instant clones get deleted when I log off. So if my virtual center is not there, it's not going to get deleted. My replacement isn't going to get provisioned. So all of a sudden my pool is running out of desktops. So how long am I happy for that to happen before stuff like vSphere HA kicks in or I can fix it? Am I going to use stuff like vCenter HA to kind of mitigate against that? Or am I going to create 2 blocks and split it? 2,500, 2,500. So don't just design to the figures I've given you. Think about whether that's right for your environment. Other thing to think of is provisioning tasks. Right? And I was having a conversation actually last night with somebody who has shift work in a hospital. Right? And at 2 o'clock in the afternoon each day, everyone goes out from the shift that just finished working, and the new shift comes in. So there's an overlap of a couple of minutes where a couple of hundred people are logging out, the desktops are getting destroyed, and then we're trying to create 200 instant clones. And it's taken a few minutes. It's fast, but it's not that fast. So there's a provisioning time lag there. So you need to think of, do I need more virtual centers there to handle that load? Do I need to kind of spread out that provisioning task amongst more components? So again, don't just design to the maximums of the best practice. Understand what's right for your environment. A little bit of summary when we look at the whole Horizon environment. As I said, the connection servers are what define our pod. You're going to have a maximum of 7 within a pod. Each of them is going to be about 2,000 active sessions as a best practice. Unified Access Gateway I will talk about. It nicely aligns. It's going to be about 2,000 active sessions running through a Unified Access Gateway. And app volumes I will get into. Sizing for that is a little bit of a dark art because it depends on your applications, it depends on how many your app stacks you're attaching, it depends on how often that's happening, etc. If you don't have any other guidance, 750 to 1,000 is a good starting point, and then monitor it, measure it, and understand what's actually realistic in your environment. But it's where we can start if you don't have any other figures. And once we get past that pod, we then talked about cloud pod architecture joining multiple pods together. And this allows us to do stuff like global entitlements. So I've got a pool of desktops from pod 1, and I've got a pool of desktops from pod 2. I can create a global entitlement that says Graeme gets a desktop from either of them. I don't really care. Now, if they're in different physical locations, different sites, we can say, I want Graeme to go to site 1. He's a home site. We can also put in search orders and actually control how we actually look for desktops as well. So there's a whole mechanism there. The other thing to think of with cloud-pod architecture, we traditionally look at it as, between two sites. But if you're doing a larger deployment and you're doing two pods within a physical location, global entitlements are actually really useful there. So I can join two pods together locally, get a global entitlement. And in fact, if you're doing a single pod, and you say, well, I've got two blocks because I hit that virtual center limit, right? But all my desktops are the same. I don't really care about which users to get which one. Just take the two blocks, create a global entitlement on top of them, right? And then your users will get consumed out of either of the blocks. And that helps also then mitigate against that virtual center redundancy. There are some limits with cloud-pod architecture. Important thing is here, every version we release, we push these numbers up. So how many sessions we're going up to, I think we're about to increase this to, I think it's 2,500 in the next version. But really big numbers, we shouldn't really hit any limits. Okay. So my aim is to try and leave 10 minutes at the end to give you an opportunity to ask any questions. We will have mics. I understand I'm kind of going through a lot of features very quickly, and there's a lot of content here. The next one I do want to talk about is Identity Manager. Now, show of hands, can I get a lot of you in the room are running Horizon? Anyone running Identity Manager? Okay. Anyone planning to run Identity Manager that didn't put up their hands here? Okay, a few. Good. So Identity Manager is made up of a few components. When we're deploying it on premises, we have the Identity Manager appliance itself. Right? It's going to run the actual service. We also have what we call a connector. And the connector service can run on that appliance as well. But typically what we'll do is run it as a separate service. There's a few security reasons, design architecture reasons you want to do that. The connector's role is to talk to other resources. Primarily that's going to be Active Directory. But if we're integrating into Horizon, it will also talk to our connection servers. If you're integrating into Citrix or other things, it will talk to that. That's the connector's role. It connects things. It will then take that information and pass it into the Identity Manager service itself in the appliance. Now, what we can do with the connector, if we separate it out, is we can say your connector is an outbound mode. So nothing can talk into it. It's the thing that talks out. It will talk out to the connection servers. It will talk out to the Identity Manager. That makes it really secure. Right? That's the reason we kind of separate it. Now, this then allows us to do some architectural decisions. We can then put the Identity Manager appliance into the DMZ. We leave the connector internally. It's the thing that talks to the things I care about, like Active Directory and all my resources. And it's got an outbound configuration, so nothing can talk directly to it. So it's secure. I'm securing that. You may say, well, why is my Identity Manager appliance in the DMZ? Really, what we're doing here is trying to design and architect for the future. Right? If you're coming from a Horizon perspective, Identity Manager appliance could sit anywhere. Right? It could sit internally. We could do reverse proxying of the web service on it. And there's really no issue. The challenge comes if you actually move up and you start doing AirWatch MDM or EMM. And you want to do stuff like Kerberos, single sign-on with iOS devices or Android devices. Some of the way that architecture works is the port from an Apple or an iOS device needs to make its way all the way through, pass through into my Identity Manager appliance. If we bring the Identity Manager appliance into the internal network, we're essentially passing those ports directly through our firewall. And I guess most of you would not be happy if I said, I need to punch a hole right through your DMZ into your internal network on a certain port and allow traffic completely unfettered into your network. So what we're doing is we're just bringing the Identity Manager appliance up into the DMZ so that if you start adopting stuff like that, you don't have to move stuff, you don't have to re-architect. Right? But another thing we're doing is taking that connector service away from the DMZ, so we're not giving you any security risk there. So it kind of gives you the best of both worlds. It's secure, but it's kind of designing for the future as well. Other things we need for Identity Manager is we need a SQL database. Right? All the information, all the configuration, all the state is held within SQL. So how do we architect this and scale? Right? We need a minimum of 3 identity manager appliances. Right? Now we can have more. Right? You probably won't need more in most cases, because each identity manager appliance will handle roughly about 100,000 users. So why we have 3 is to mitigate against Elasticsearch, which is a kind of service that runs across that, and a caching technology we use there. And it also reduces against split brain. So we kind of recommend if you scale above 3, you stick with an odd number. So 3, 5, 7, etc. Again, if we've got an odd number, we mitigate against a split brain. So we had 4, and I lost 2. Which one's the kind of remaining one and stuff like that? Makes it harder to decide. Database as well, we want to kind of make redundant. And there's a few ways to make it redundant. Within a site, we can do SQL always on, or we can just do Windows clustering. As long as that database is highly available in some way, we're kind of good with the design. Right? If you've already got a SQL infrastructure in place and you're happy with the methodology around about that, use that SQL infrastructure as well. As long as you understand the load that we're going to put onto that SQL infrastructure. One important thing with Identity Manager and that appliance, that web service we're talking about, we do need split DNS. And by split DNS, I mean if I'm coming from outside and I'm using an external DNS, the FQDN I look at and refer to my Identity Manager service as a user has to be the same FQDN that I'll use internally. The reason being the appliance has got an FQDN setting in it, and once we change that FQDN setting, that's the only thing the Identity Manager is going to answer to, essentially. If we don't use that FQDN, we're going to get stuff not working. So, we need to use the same FQDN internally, externally, even if they're talking to 2 separate DNS infrastructures. So how do we do multi-site, right? Identity Manager is really important once you start adopting it, because it becomes the single point of use for your users. You know, it's where your users are going to log into, they're going to launch their applications, you're probably going to turn on stuff like Workspace ONE mode within Horizon. That's where they're going to be launching applications. So you really want to make this highly available if you're doing it on premises. So how do I architect this? Really, we start at the database level. That's where all my state information is. So at the SQL layer, how do I make that site redundant? And as I said, this is going to be SQL always on. So at the site level, we're going to use that Windows clustering, and we're going to then make the database highly available locally. And then we're going to use SQL always on top of that. And you may say, well, you could just do 4 nodes of SQL always on. Is that not simpler? It is, and it's absolutely an option. It's up to how you want to architect SQL. The reason we chose this architecture was it made the failover simpler. Right? From a SQL always on instance, we have 1 active copy in site 1, and we have 1 passive one in site 2. So if I lose site 1, SQL will actually automatically recover. It will actually promote site 2 instance to be its right copy now. If I have 4 nodes of SQL always on, I have to manually intervene. Right? I have to go, this is the one I want to promote. So both will work, just a slight difference in how you actually recover. So once you've got that database level in place, you're going to build out your appliance nodes. Again, in the DMZ is a recommendation, but not the only option. Again, minimum of 3 appliances into my DMZ in site 1. And then we're going to front them with a global load balancer. Now, global load balancer is a bit of a funny name. I like to think of them as kind of fancy DNS servers, right? And that's really what they're doing with a bit of kind of geolocation technology. And essentially, it's going to be able to refer stuff to site 1, to the load balancer in site 1, or to a load balancer that's going to be in site 2. And that's all it's going to do. Now, what importantly we're going to do is we're going to set up an active connection, so it's going to refer everything to site 1. And I'll show you why that's important. Because when we put appliances in site 2, where are they talking to for their database? Right? they're actually, I don't know if I have a laser in this one. No, laser's not working. So what they're actually doing is, if I actively send any user traffic to the appliances in Site 2, they're going to cross WAN talk to the SQL always on listener, and they're going to go to the right node in Site 1. So all of a sudden, I'm reading from an appliance in Site 2 to a SQL database in Site 1, which is really bad. So what we actually do is we put a standby connection. I can have the entry there in my global load balancer, but I'll disable it, and I'll activate it when I have a failure. So all my active referrals of people hitting my global load balancer are going to get pushed to Site 1, and that's my active instance of Identity Manager now. So Site 2 is really their passive just in case. This is the way that Identity Manager has to be architected. One site is your active one, one is your standby. And of course, we separate out the connector, so we need connectors in both sites. We also want to mitigate against site failure. We don't just want a single connector in Site 1 and then have to fail over to Site 2 because I lost a single server. So build 2 connectors. We don't need a load balancer in front of them. They're outbound connections. They get load balanced automatically from the appliances, so they will get used both actively. Now, you then got a choice where you point them. Where do I tell the connectors how to connect into the appliances? Well, you could tell it to connect directly to an appliance, but then I'd need 3 different connectors talking to each of the different appliances. We could point it towards the local load balancer, but then I'd have 2 different configurations for each site. Or we can point it towards the common namespace of my global load balancer. So both the local load balancer and the global load balancer will work. It just depends on whether you want the same configuration within a site or across the sites. And obviously we need connectors in the second site, and again we'll point them at that global namespace. Again, you see then I've got my connectors in Site 1 and Site 2 with an identical configuration. I don't have to treat either site differently. Ultimately, what you end up with is a service that you can then build in as part of what you're delivering to your users, but recognize that if we're delivering Identity Manager, it's actively going to be out of Site 1, passive in Site 2 for all my users. And then when I've got an outage, I'm going to be able to recover it. And I'm going to recover it at 2 levels. The SQL needs to fail over. If I'm using SQL always on, I need to make the other node in Site 2 my right node. And I need to go to my global load balancer and say, send all my traffic to Site 2. So 2 failover steps there you can build in. So app volumes. I will go through this quite quickly because we're running time. Main components. Really, we're going to stick an agent inside the virtual desktop of the RDSH hosts. It's going to communicate at either power on or log on out to my app volumes managers, which talk to Virtual Center as my vSphere hosts, also stores all the state information in a database, SQL again, so SQL becomes important. And ultimately what they're going to do is mount a bunch of VMDKs, virtual disks, against the virtual machine that I just logged onto, and give me those app stacks. That's the moving parts of it. Architecture-wise, there's a couple of options. This is the one we recommend when we come to multi-sites. So we're going to have more than one app volumes manager in front of a load balancer. The app volumes agent I talked about will refer to that load balance name, so it's not tied to any one app volumes manager server. Those app volumes manager servers will talk to the virtual centers, my vSphere hosts, and also store all that information about the app stacks, the entitlements, what's actively happening in SQL. We reproduce that completely on Site 2 with a separate SQL database, so completely separate. This keeps them kind of isolated, so if I have a failure on Site 1, I can actually have a completely separate infrastructure in Site 2. It's not touched at all. The only challenge you've got here is any entitlement I make to an app stack in Site 1, I'm going to go and have to reproduce that in Site 2. The other thing you need to think about is your app stacks. Right? If I've got app stacks with applications in them in Site 1, you want to get them copied over to Site 2. Right? Especially if I want to fail over your desktop to Site 2, I want to give you the same app stack. I don't have to recreate it there. So we can use storage groups to achieve this. So storage groups are a way of grouping together data stores, and then any app stack that drops onto one data store will automatically get replicated out onto the other data store. So in this model, I create a storage group 1, and anything that goes onto data store 1 will automatically get copied to data store 2. And on site 2, I do something similar. So anything that's on 4 will go to 5. And then I use a middleman, right, data store 3. And I can actually tick a box that says, make this non-attachable, which means never ever use this for production. Never attach anyone's app stack from this version of it. So we don't actually care about the performance of that. So that can be really low. It can be like NFS, really low performance storage, because all it's there for is to copy these app stacks in when they change and copy them over to the other side. And all we do is extend the storage groups. So anything that's on 1 will go to 2, will go to 3. And if I extend the storage group on the other side, anything on 3 will then make its way onto site 2. All we need then is one vSphere host at a minimum from each site to see that middleman. Then all app stacks are going to be able to replicate between storage. There's other ways to get app stacks there. If you say, I don't have the bandwidth to do that, you can export them. You can go with a USB key to the other side, plug it in, copy them out as well. Lots of ways you can do it. This just helps automate it. Other challenge you think about is writable volumes. What I will say with writable volumes is approach with caution, right? You're essentially giving your users a black box, right? And saying, you can put whatever you want in it, and I'm responsible for it. So think about the templates you're going to use, what the use cases are. Generally, we tend to steer away from profile information in writable volumes. There's better ways of handling that. But stuff like user-installed applications, absolutely. But think about how you're going to replicate them, back them up. There is options in the GUI now, so you can actually kind of do scheduled backups of them. But where are they getting replicated to? Is it within the site? How do I get them into site 2? How do I recover them? What does that mean as part of the overall service? And ultimately, what you're going to end up is, if you're doing app volumes as part of the service, it's probably going to be an active-passive service. Now, if it's just app stacks, we showed how we could replicate app stacks from site 1 to site 2. So I can actually deliver those active. I don't care, you're going to get the same app stack from either site. That's read-only data. That's really straightforward to replicate. When it's stuff like writable volumes, that's user changing data, that's more challenging to replicate over and say, yes, I'm going to guarantee it's there. So you kind of look at that as being something I'll have to decide that the version of site 2 is now going to be an active one. So you can mix and match these. So User Environment Manager becomes quite important then in providing a persistent, non-empty desktop. Two main components here, because it's all file data. Two file shares, one that is going to be our IT configuration. This is read-only to users. And the other one is our profile data, our profile archive. That's where we allow users to save their personalization. So two different file shares, keep them separate for various reasons. The reasons we keep them separate are this. The configuration share is what we decide as IT is the right settings. It's read-only to the users. So we can replicate this out with stuff like DFS, and we can also use DFSN to say there's multiple entry points, there's multi-referral points, and they're all active. So I'll replicate it out onto different file servers in different regions, use stuff like Active Directory sites to control that you go to the closest one. And that's all fine, because users aren't changing that. Right? So there's no conflict. There's no potential for users changing data in site 1 and it getting replicated out. Now, the only people changing it is IT. So as a discipline, what we say is, when you run IT, choose one version that you're going to connect to directly. You won't use the DFS namespace. You'll use the local server name. You change one copy. And that just removes the possibility of two administrators working on the same version, but using different file servers, and then replicate and overwrite each other. The challenge then with User Environment Manager data is that user data, where we're allowing users to replicate data. We have a couple of rules we need to follow because it's Microsoft profile data. And they state, if you're dealing with replicating Windows profile data, only one copy of it can be active. Don't have two servers that I'm able to write to that are then replicating and can potentially overwrite each other. They don't support that. So what we have to do is, we can replicate it, but we've got to keep the copies of it passive. Right? So if I'm using DFSN, I'm going to have those refer points disabled. And then when I lose my initial server, I'm going to need to go and promote that one. And then what you end up with is a component you can fit into your service for User Environment Manager. Now, the one I've drawn here is somebody consuming it in an active. And I did that to highlight some of that user data is going to come from Site 1, because I need to choose one place for that to be, to follow the Microsoft rules for profile data. So it's sitting in Site 1. So even if I log onto a desktop, my profile data might be getting read from Site 1. Now, the IT configuration, that read-only, that's fine. That'll come from Site 2. That'll come locally. And this may kind of drive you to say, well, personalization, you may not get it in a disaster. I don't care about you change the menu in Word. Bigger challenge there is user files I've talked about. Okay. Unified Access Gateway. Who is still running security server? Who wants to replace security server with Unified Access Gateway? A few hands went down there. You need to think about replacing it. So, no shocker. Like, security server is going to go end of life. Right? I'm not announcing it. It will go end of life in 1 or 2 versions. And that will mean you've got a choice. You either stay in the version you're running, or you replace it with Unified Access Gateway. And lots of reasons that I can't get into in terms of time here, why Unified Access Gateway is a lot better architecturally. One of the main reasons, so one I'm going to touch on, is you get away from this one-to-one pairing. So architecturally, with Unified Access Gateway, we get away from having to pair a device in my DMZ to a connection server. And that was painful because we tied up a connection server with security server. So architecturally, it was very constraining. There's lots of other things we can do with Unified Access Gateway that we couldn't do with security server. So with security server, it essentially did what we call pass-through authentication. It just kind of blindly passed all the traffic through to my connection server and let it handle authentication. With UAG, we can actually say, no, we want the Unified Access Gateway to perform the authentication, or we wanted to talk to our third-party Radius server or whatever else. And then, once it's passed those authentication steps, then we'll forward it into the connection server. So a lot more secure. So architecturally, that didn't build very well. Architecturally, it looks like this. Yeah. With security servers, we tend to have 2 different groupings of connection servers within my pod, because I needed to pair a connection server to a security server. The minute I do that, my connection server goes into tunnel mode. The tunnel mode's kind of pushing all the protocol sessions through that connection server, which is then a bad idea for my internal users. So what most people then did was they have a separate set of connection servers that are grouped separately. And I've got one namespace that I allow my internal users, and I've got a separate one that I push all my security servers through. Architecture is a little more complex. What we look then with Unified Access Gateway is there's no one-to-one tunneling, there's no kind of pairing up, so we can have one common set of connection servers, and we can point our internal users at the load balancer in front of those connection servers, and then we can have one group of Unified Access Gateways, and they point at that same namespace. So my connection servers will handle either internal or external traffic. Right? The important bit here is there's no tunneling turned on the connection servers. So it simplifies down the architecture. So for those of you we're still kind of running security server, we are looking at kind of doing a few assets to help you kind of understand how you migrate, how you re-architect in this move. One thing I will mention, there are 2 different sizing in UAG, how you scale this. When you install it, you've got an option, standard or large. When you're doing Horizon, it's standard. Never choose large. Right? It's just a waste of resources. They're exactly the same build. just more CPU and memory. And all you're doing with choosing the large for Horizon is just wasting the resources. For Horizon, as I said earlier, 2,000 sessions per UEG. Last thing I want to talk about in technology, in kind of infrastructure, is don't just limit your scope to, I know you said a number there, but I couldn't see the board. So somebody's holding my card to me. Don't just limit, thank you. Don't just limit your scope to the VMware software. Think about the surrounding infrastructure, the impact on that. Think about stuff like if I'm running published applications that uses RDS8 Windows servers, I need RDS8 licensing. So do I have enough of those? Do I have them redundant? Am I using stuff like DHCP? Probably if I'm doing stuff like instant clones. What's the throughput on that? What's my lease period? If I'm creating Active Directory computer accounts through instant clones, what's the load on my domain controllers, and can they handle that? So think about the surrounding infrastructure. Think about whether actually any of that needs to change as well. And then once you've got all that in place, start going back to those blueprints and building what you said would solve the user problem at the beginning. So look through this. We've now got all these infrastructure in place. I can now build these things called instant clones. I can now build app stacks, and I can have them replicated if I need. So you can refer to each of those and build out a kind of task list, right? Because it's not as simple as, oh, I'm going to build a clone. I'm going to build a pool. How do I create that master VM? Right? So we give them guidance. There's actually a great white paper from one of my colleagues on how to build a Windows 10 master VM from start to finish. Screenshots with all the different versions of Windows 10. How do you create stuff like mandatory profiles? How do you actually build and optimize it? Right, so that's one of the tasks. So you're going to go through creating that master VM. You're going to install Windows. You're going to optimize it. And once you've got that, you're going to create the pool, based on what your requirements are for that pool. And that's going to get you the OS. And maybe you said my applications are including stuff like app stacks. Or maybe I'm doing application virtualization or isolation within app. So maybe that's part of my application delivery. So how do I create them? How do I follow the rules to make them available, as I said? Do I need to go and create those storage groups to make sure my app stacks are in Site 1 and Site 2? Go through that process. If I'm going to bring some of the applications into Identity Manager, maybe I'm integrating also SaaS applications in there. I want to drive all the Horizon resources into that. Right? So build those bits together. And then lastly, your profile data. Don't think of this, just use Environment Manager. And I mentioned mandatory profiles. And that can be a key way of helping put a baseline down on top of Windows to help then put the personalization through User Environment Manager on top of. You may also be doing stuff like folder redirection. You may kind of be saving all the files outside. So don't think of the profile information as just being one configuration. Lots of things moving back there. Now, I've whizzed through the content there. The white paper itself is out in TechZone. So techzone.vmware.com. Let's show of hands. Who has been to TechZone? Okay. So probably about a third of the room. The other 2/3, please, if you do nothing else, go to techzone.vmware.com. We have a wealth of information, guides, how-tos, quick starts, videos, and the reference architecture in all its 350 pages. Don't read the whole thing, dip in and out, look at the contents, and go to the section that's important for you. Now, before everyone runs out, there is a survey. Please fill in the survey if this was interest to you. I will kind of be around for about the next 5-10 minutes in this room, and I'll hang about outside. And with that, we'll take some questions. So there are some mics if anybody has a question.